Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to be talking about straight lines in vectors. So how do you define straight lines in terms of vectors? Now you would need a little bit of coordinate geometry knowledge for that, and I think you'll have that knowledge because if you're studying vectors you'll definitely have the knowledge of coordinate geometry, which states that if, let's suppose, the coordinate geometry states that if you have a line, I'm just revising this knowledge, if you have a line like this, then the equation of the line is something which is denoted as y is equal to mx plus c, where m is the gradient of the line, or it's also called as the slope of the line, right, which is actually equal to the change in y divided by the change in x, right? And c is the y-intercept of the line. So this is something that we have done in the coordinate geometry videos. So y-intercept would be this point, this distance over here would be the value of y-intercept. Well, how do you define such a system in vectors? Well, this is a collection of points. What if I say that you have vectors, and how do you define such a system in vectors? So let's say, for example, I have a point A which has coordinates x1 comma y1, and I have point B which has coordinates x2 comma y2. So let's suppose I have these 2 points and I want to define the line AB. I want to define the line AB, right? So what do I want to do is I want to find the equation of line AB. That's what I want to find. I want to find the equation of line AB. So let's say, for example, if I draw the vector plane like this, let's say this is the y-axis and this is the this is the y-axis and this is the x-axis. So if, let's suppose, I say this is vector A, this is point A, which is x1 comma y1, and let's say this is point B, that is x2 comma y2. So what I want to do is I actually want to define this line right here, which is AB. Now what I'm going to do is I'm actually going to define a point R here somewhere. I'm going to define point R here somewhere such that AB is actually lambda times AB is equal to AR. That's what I'm going to say. I'm going to say lambda times AB is actually equal to AR. Fine. So that is what I'm going to do. Let this lambda be any real number, because it's going to be a real number. So I hope you've understood what I'm trying to say here. I've actually picked up a point. I say that if this is the length AB and this is the length AR would be just half of AB or 1/3 of AB or 1/4 of AB. It can actually be any given point, right? Now what I'm going to do from here, I'm going to define vector AB to be equal to u. I'm just going to give this value u. So that means this whole thing is equal to u. That means vector AR is actually going to be equal to lambda u. So vector AR is actually going to be lambda u. So this vector is going to be lambda u. I'm going to define vector A to be A. That means this vector is going to be A. And I'm going to define vector, so that's OA, basically OA, it's A, and vector OR to be actually equal to R. So vector OR is actually going to be equal to R. So this is what I have. And if I draw this, this is A and this is R, and this is OA, and this is OR, and this is lambda U. Fine. So this is in this direction, this is in this direction, this is in this direction. Now, let's suppose if I want to say, so how do I reach? So I can say that R is actually equal to vector R is equal to A plus lambda U. Vector R is equal to A plus lambda U, because as you can see that R is kind of the resultant for A and lambda U. So if I talk from displacement from a point of view, if I'm standing here and I want to reach here, either I can go like this or I can go like this and like this. So I can say that R is equal to A plus lambda U, and this gives us the equation of the line. This gives us a method to actually define any point R on the line AB. So since r, I'm going to define the vector r to be, let's say, equal to uh, x and y. Let's suppose it has components x and y. I'm going to define vector a to have components x1 and y1. I'm going to define u to have components u1 and u2. So from here, from this equation, what we can say is that vector xy is actually equal to vector x1 y1 plus lambda times vector u1 u2. So that means from here I can actually say that x is equal to x1 plus lambda u1, and y is actually equal to y1 plus lambda u2. So this is what I get from here. So both of these equations are known as parametric equations, right? So both of these equations are known as parametric equations. I hope you're able to understand what I've just done here. Now, if I can actually pick up the parametric equation, so what are the parametric equations? X is equal to, the parametric equations are x is equal to x1 plus lambda u1 and y is equal to y1 plus lambda u2. So from the first equation, I can say that lambda is equal to x minus x1 over u1, and from the second equation I can also say that lambda is equal to y minus y1 over u2. And equating both of the equations, if I equate both of them, I can actually say that x minus x1 over u1 is equal to y minus y1 over u2. And from here we can say that x minus x1, or let's say we can say that y minus y1 over x minus x1 is actually equal to u2 over u1. Now if you remember the coordinate geometry, now this is something which is known as the Cartesian equation. So if I equate this equal to our coordinate geometry equations, a coordinate geometry equation says that y minus y1 over x minus x1 is equal to the slope of the line. That means I can say that the slope or the gradient of the equation, or slope or the gradient of the equation, is actually equal to u2 over u1. And again, if I put that in the form y is equal to mx plus c, where c is equal to y minus mx, that means c is the y-intercept of the line. If I put that in that form, that means I'll be able to say that c is equal to any y value, let's say we pick up y1, minus the slope, which is u2 over u1, into the corresponding x value. That will give us the y-intercept. So this is the Cartesian equation, and this is the Cartesian equation, and this is the the slope and the y-intercept of that particular vector. Now let's go ahead and do a question on this so that you're able to understand this. But before I do this, I'm just going to summarize what I just did here. So the summary would be that if you have a vector AB, so let's suppose this is A and this is B. So the vector AB is going to be U1 and U2. Vector A is going to be equal to X1 and Y1. Any point R on the vector, would have, again, this is vector OA, I'm sorry. Any point R on the vector would actually be defined as, so R is nothing but X and Y, would be defined as R is equal to A plus lambda, this is, let's say, equal to U. So this is known as the vector equation of that line. And if I just put that vector equation in terms of, let's suppose if I put this vector equation in terms of the vectors itself, I can say that x and y is actually equal to A is equal to x1 y1 plus lambda u1 u2, right? So this will give me a Cartesian equation. This will give me a parametric equation, right? And if I take the values of lambda out, and I get x minus x1 y minus y1 divided by x minus x1 is actually equal to u2 over u1. That is a Cartesian equation for this. Fine. So I hope you're able to understand what I'm trying to say here, guys. So let's go ahead and solve a question on this, right? So let's pick up a question. All right. So let's see this question. So this question over here says that a vector A is there. So you have a vector A, which is 1 comma 3, and you have a vector B, which is 2 comma 5, right? So that means your vector OA, which represents your x1 and y1 value, is going to be equal to, so OA, it's just going to be equal to 1 and 3. And your vector OB, it's simply going to be 2 and 5. Again, vector AB is going to be equal to, which represents u1 and u2. This is vector u, that is going to be equal to OA minus OB. You can see that, sorry, OB minus OA. If you've seen the previous videos of vector, you would understand that vector AB is equal to vector OB minus vector OA. So OB is 2 minus 1, which is 1, and 5 minus 3, which is 2. So that is what a vector U is. Now the question is asking calculate the vector equation. So we have, let's suppose there's a vector R that is going to be equal to A plus lambda U. That is the vector equation, A plus lambda U, right? So that is going to be the vector equation, which means R is just going to be any x or y value, and this over here A is going to be equal to 1 and 3, and this is going to be lambda, and U is going to be equal to 1 and 2. So this is going to be the particular vector, like the vector equation. Now how we'll get the parametric equations from here? Parametric equations are very easy. There are two parametric equations. First one would be for x, that is x is equal to 1 plus lambda, x is equal to 1 plus lambda, and y is equal to 3 plus 2 lambda. These are going to be parametric equations. X is equal to 1 plus lambda, y is equal to 3 plus 2 lambda. And then for Cartesian equations, what do I have to do is, I have to just get rid of the lambda. So from here, you can say that lambda is equal to x minus 1. And from here, you can say that lambda is equal to y minus 3 over 2, which means that x minus 1 is equal to y minus 3 over 2. And from here, I can say that 2 is equal to y minus 3 over x minus 1. That is our Cartesian equation. Another way of getting Cartesian equation is very simple. It says that y minus y1 over x minus x1 is equal to u2 over u1. So what is y minus y1? Y minus y1, and you know the value of y1 is 3, divided by x minus x1, you know the value of x1 is 1, is equal to u2 over u1, which is 2 over 1. That gives us exactly the same thing. As you can see, this is u2 and this is u1. It gives us exactly the same thing that we're trying to find. Fine. So I hope you're able to understand what I'm trying to say here, guys. So let's move forward. So thank you very much for watching this video, guys. Thank you very much. And in this video, we covered the vector equations. It was just an introduction for equations. In the future videos, equations for straight line. In the future videos, we're actually going to be talking some special cases. Also, we're going to be talking about, vector equations for 3 dimensions. Just to summarize this, that if you have this point A and if you have this as point B and this is vector U, then you can say that vector U is U2 and U1, which is basically vector AB, which is basically vector OB minus vector OA. Another thing is that vector A is represented as X1 and Y1, and any point R, vector OR is actually represented as X comma Y. So if you want to find any value of R, that can actually be found as vector A, so this is vector A basically, plus lambda U. This is the vector equation, and from there you get all the other equations. You get the parametric equation, you get the Cartesian equation, and that'll be really helpful for your studies. So thank you very much for watching this video, guys. Make sure that you give us your valuable like on this Facebook page, you explore our website, and give us your valuable feedback on this email address. Follow us on Twitter. So thank you very much, and I'll see you in the next one.